Hey, it's Professor Gould, and in this lecture, we're going to start talking about energy. So we're going to start off with what is energy, what forms does energy take, particularly kinetic and potential energy. We're going to define how the term we use for energy, which is a calorie. And then we're going to understand heat, specifically this term specific heat. We're going to define what happens in various changes of the state of matter. And then we're going to understand these terms exothermic and endothermic and what those mean in terms of chemical reactions. All right, so let's start off with thinking about what exactly do you mean by energy? So think about an energy drink. Red Bull gives you wings. What is it about the Red Bull that gives you wings? Well, primarily it's two things, caffeine and sugar. And for those of you who are like, oh, I don't drink Red Bull, I drink this other thing that doesn't have caffeine and sugar in it, I guarantee you it has other things that act the same as caffeine and sugar. So caffeine, of which Red Bull has quite a lot, is going to have an effect on the brain by blocking signals that tell you you're tired. So that is a different physiological mechanism, and we're not going to worry about that one for today. Today we're going to focus on the sugar because the energy in sugar is in the chemical bonds in the sugar molecules. Now, what I think is interesting is that if you look down here on the ingredients, Red Bull has carbonated water, and then it has sugar and glucose. Anything that ends with OSE is a sugar. So glucose is a sugar. Sugar is table sugar, which is sucrose, which is a molecule of glucose bound to a molecule of fructose. So what they've done is they took table sugar and then they added more glucose. The reason this makes you feel energized is that glucose immediately goes to your cells because that's the sugar that your cells use most. This one takes the glucose and fructose get separated. The fructose has to be processed by your liver. So the table sugar is a little longer acting, not very much, honestly. Okay, so that's how Red Bull gives you wings. All right, but let's talk about what energy is exactly. So energy in the chemistry and physical sense is the capacity to cause change or do work. Work is just moving something from one place to another, okay? So if you're moving an object against an opposing force, that requires energy. That's work. If you cause a chemical reaction to happen, that requires energy. That's work. Energy is not created or destroyed. We already learned about the conservation of matter. Yes, energy is also conserved in the universe, which is the first law of thermodynamics. The total amount of energy in the universe is constant. And so we can transform energy from one form to another, move it from one place to another, but we can't create it or destroy it. So it's very important when you're talking about these reactions and these mechanisms that we're going to talk about, that you never use the words created or destroyed when you're talking about energy or matter. Use the word transformed. All right. If it helps you to think of this, Einstein's equation E equals mc squared. The E is for energy, M is for matter, and C is for the speed of light. So what it means is that energy and matter are the same thing. Energy equals matter at the speed of light squared, which, let's admit, is really fast. The circumstances in which energy and matter get transformed one into the other really only happen in very unusual circumstances, like in the pressure inside a star. But if it helps you to remember that energy and matter are the same thing and neither one is created or destroyed, the universe only has so much of them, then there you go. All right. Now, today we're going to focus on energy. We've been focusing on matter. Today we're going to focus on energy. All right. There are two forms of energy. I know you're thinking, wait, hang on. No, there's lots of forms of energy. They're all categorized in two forms. The first is potential energy, which is stored energy. This is energy that has been stored up either because of an object's location, where it's pulled on by gravity, or its structure. A compressed spring has energy in that compression, and then when you release the spring, you release that energy. And chemical bonds have energy stored in those bonds. And when you break those bonds, you release that energy. Now, kinetic energy is the other form of energy, and it is the energy of things in motion. So if you think about it, a car at rest has less energy than a car moving toward you. If you get hit by a bus going 1 mile an hour, the bus is going to transfer less energy into you and hurt you less than if you get hit by a bus going 50 miles an hour, right? Because the 50-mile-an-hour bus has more kinetic energy because it's moving faster. Make sense? So these things get transformed one into the other all the time. Burning gasoline transforms the chemical energy in the gasoline into kinetic energy in the engine parts that gets transformed into the kinetic energy of the tires that moves the bus. Heat is kinetic energy of atoms and molecules moving around. So just remember that heat itself is a form of kinetic energy. It's not stored energy, it's kinetic energy, okay? All right. Now, all of these conversions, anytime you transfer kinetic to potential heat or potential to kinetic heat, all of those are going to release a little bit of heat. So every time we do one of these changes, we release a little bit of heat and the system loses a little bit of heat. It doesn't disappear. It just goes out into the environment, okay? All right, now chemical energy. Chemical energy is the one that's important physiologically because this is how your cells do things. Chemical energy is the energy stored between atoms, and it doesn't matter what kind of bond it is, whether it's a covalent, an ionic, or a hydrogen bond. Those bonds store energy, and those bonds are a form of potential energy. A stronger bond stores more energy. Okay. Now, creating bonds uses energy, obviously, because you got to put the energy into those bonds. Breaking bonds releases energy. It may take energy to get a reaction started. So if you think about striking a match, you're using a little bit of energy, putting friction into that match to get that reaction started. Once you get it started, the reaction continues burning the match on its own, releasing a lot of heat energy. That make sense? Okay. All right, now, how do we measure energy? We measure it in a unit called a calorie. Now you're thinking, yeah, I know what a calorie is in food, right? Like the Red Bull had 110 calories. No, this is a different calorie. Why? Because I don't know. They hate us. A lowercase calorie, lowercase c, is the energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. That is the definition of a calorie. The uppercase C is a kilocalorie. Now there's kilo, that means 1,000, right? So a kilocalorie is 1,000 calories. But that's the same thing as the calorie on a nutrition label. There we go, label, or the thing you think of as calories. So this 110 calories in Red Bull is actually 110 kilocalories, or 110,000 lowercase c calories, which is enough to raise the temperature of 1 gram of water by, I did this wrong again. It's supposed to be 110,000 calories. 110,000 degrees. Yeah, it's 110,000 calories. Or raise the temperature of 110,000 grams of water. There we go. Sorry about that. Oops, there we go. All right, now, inside your cells, which is what's going to be important in physiology, your cells are going to use energy primarily from chemical energy, stored energy in the form of chemical bonds, to make large molecules. So we're going to transfer the energy from one molecule into another molecule, okay? To move things. Whenever you move a muscle, you are physically changing the shape of proteins inside your muscle cells, and we require energy to make every single one of those physical changes, and that comes in the form of breaking chemical bonds. When your cells go to release hormones, That requires moving things around in the cell, and that requires energy in the form of chemical bonds. When you break down large molecules in the digestive system, even though breaking those molecules down is ultimately going to release energy, you need some energy in the form of chemical bonds to start that breakdown happening. Okay? So all of this is really important physiologically. And the way you get energy into your body is in the form of food. Now, I recommend that you get energy into your body in the form of like real foods, not processed foods, as much as possible. Fruits and vegetables, rather than Red Bull, will actually provide you with longer lasting energy. That being said, if you got to take an exam and you're falling asleep, sure, enjoy a Red Bull or some other energy drink. Every once in a while, it's fine. All right, on the next section, we're going to talk about some more specific things related to heat.